Hello, this is OCR Further Statistics. We're in Discrete Random Variables 3 and the second video, calculating probabilities using the geometric distribution. This is the tree diagram we had in the last video for the first 3 rolls. We'll be able to identify the pattern from this. We won't assume that the die is fair. We'll take the probability of success to be P, so that it is more general. And we'll use the usual convention that Q equals 1 minus P, so that the probability of getting a 6 is P and the probability of not getting a 6 is Q. So let X be the number of rolls until the first success. Then the probability that X equals 1 is just P. We get a 6 on the first roll. If X is 2, then we must have not got a 6 first and got a 6 on the second roll, so that's Q times P. If X equals 3, we must have got 2 not 6s and a 6, so Q squared times P. And for X equals 4, we fail to get a 6 3 times, so that's Q to the 3 multiplied by P. In general, the probability that X is equal to X is Q to the X minus 1 multiplied by P. If we're writing this formally, we'd usually use 1 minus P rather than Q, so that it is completely unambiguous. But you'll probably find it easier to remember using Q. Here's an example. Remember that we interpret this as 6 friends including the guesser. So the probability of guessing correctly is 1 in 7, so P is equal to 1/7, and X is geometric with parameter 1/7. The probability that X is equal to 6, using the formula from the previous slide, is P multiplied by 1 minus P to the power 5, which in this case is 1/7 times 6/7 to the 5, and that comes out to be 0.0661 to 3 significant figures. Here's another example. We define X to be the number of throws until we get a double. So that's a double 1 or a double 2 or so on. 6 possibilities out of 36 possible throws. So the probability of getting a double is 1/6. And therefore X is geometric with parameter 1/6. Find the probability that a player starts within 4 attempts of throwing the dice. So we're looking for the probability that X is less than or equal to 4. So the probability that X equals 1 plus the probability that X equals 2 plus the probability that X equals 3 plus the probability that X equals 4. In general, that's P plus P times 1 minus P plus P times 1 minus P squared plus P times 1 minus P cubed. You'll see that each term has been multiplied by 1 minus P. So you'll be getting a sense of why this is called the geometric distribution. So in this case that's 1/6 plus 1/6 times 5/6 plus 1/6 times 5/6 squared plus 1/6 times 5/6 cubed. And that comes out to be 671 over 1296, which is probably more sensibly written as a decimal 0.518 to 3 significant figures. Here's an alternative way of thinking about this. Same situation, but this time, instead of calculating each of the terms for x less than or equal to 4, we'll work out the probability of x being greater than 4 and subtract that from 1. Now, the probability that x is greater than 4 is what happens if we don't get a double until after the fourth go. So that means 4 non-doubles, which is 5, 6. And we're not interested in what happens after that. We're just saying that on the first 4 goes, we don't get a double. And we can work that out as a single calculation, and it comes out, of course, to be the same as the answer we had earlier. It's probably also worth noting that some graphical calculators do have the geometric CPD. In summary then, if x is geometric with parameter p, then the probability that x is equal to x is p multiplied by 1 minus p to the x minus 1, and the probability that x is less than or equal to x is equal to 1 minus p to the x. That's the end of this short video on calculating probabilities using the geometric distribution. The next video looks at the mean and variance of the geometric distribution.